Again, welcome to more Algebra 2 Notes with Miss Faust. Today we will be looking at how can you solve square root and cube root equations using algebra. So we've been going back and forth with exponents and roots, and today we're going to look at just how we solve equations if we have roots in them. Or if we have those fractional exponents, which we know we can change into roots. But before we get into that, let's have a joke for today. Why did the teacher write the math problem on the window? Because she wanted it to be very clear. Okay, enough fun for now. Let's get right into it. So we're looking at solving square root and cube root equations using algebra. And I say equations, these have equal signs in them, so that's what makes them different from what we've been doing before. So for example, this is a square root equation. Remember, there's a little hidden 2 here. This is an example of a cube root equation. So we have equal signs now, which means as we do these, our main goal, as always when we have equal signs, is to isolate the x and find the value of x. We're not just manipulating anymore, which is what we've been doing before. We're trying to get to a single answer or answers for the value of x. So the steps in these, the good news is they're the same whether you're doing a square root function or a cube root function. They're also the same as all other equations that you've solved. So the couple additional things is we want to first rewrite our equation with radicals. Remember, radicals is another word for roots. So if you have a problem that has a power of 1/2 or 1/3, you would rewrite it with roots first. Next, you're going to isolate the radical. So you're going to move everything to one side. So you just have a square root or cube root by itself. Then you're going to square or cube both sides. And that's going to depend on if you have a square root, then you'll square it. If you have a cube root, then you'll cube it. Because a square undoes a square root, a cube undoes a cube root. And I realize on the screen those look the same. That's a little 2, that's a little 3. Okay, once we've done that, then we solve using inverse operations. And remember, our order of operations is subtraction, addition, division, multiplication, roots, exponents, and finally parentheses. So we go in that order when we solve. And then the last thing we always do is we just check to make sure we don't have any extraneous solutions. And that won't happen too often in Algebra 2, but eventually as you get into pre-calculus, sometimes you'll have extraneous solutions to look at. So let's jump right into an example. Because I think once you start seeing examples of this, you'll be like, oh, this is totally like what we've done before, Miss Faust. Why must you make it so simple for us? So, hey, I do what I can. Example 1, 2 plus the square root of x plus 10 equals, not 10, I'm sorry, equals x. So when we look at this, notice that we don't have the radical by itself. So what we want to do first is we want to isolate that and get it all alone. In order to do that, I'm going to subtract 2 on both sides, and I'm going to get the square root of x plus 10 equals x minus 2. So far, so good. Now we've isolated the radical because we have a square root by itself over here. So we're going to either square or cube both sides. So when I look at this, because this side has a square root, I'm going to square both sides. When I square both sides, over here I get just x plus 10. Over here I get x minus 2 squared. Well, I got to do a little bit more work then to solve that. So I look at that, and x plus 10 equals, when I do that, I use box, right? And I do x minus 2 and x minus 2, and I get x squared minus 2x minus 2x and 4. You might not see all that, but you've done boxes lots of times before, so you've got an idea of that. X squared minus 4x plus 4. I see now this is quadratic. I'm going to move these things over here, minus x minus 10, and get 0 equals, subtract another x, subtract a 10, x squared minus 5x, 4 minus 10 is minus 6. I take a look at that, I think, I could use a quadratic formula. I could think about whether I know two things that multiply to negative 6 and add to negative 5. My first instinct is negative 2 and negative 3, but negative 2 plus negative 3 is not negative 6. But if I think for another minute, I realize that negative 6 and positive 1, negative 6 and positive 1 work because negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5, which means either x minus 6 is 0 and x equals 6, or x plus 1 is 0 and x is negative 1. So my two answers are 6 and negative 1. Neither one of those would give me imaginary solutions here, so I'm good. So my two answers are 6 and negative 1. Again, the only new steps are this isolating the radical and then squaring both sides. You've probably used that before. Actually in reverse, you've taken the square root of both sides. Now we're just squaring both sides. So let's do a couple more examples. We won't do too many because the sun's out and I want to go outside and so do you. So we'll put questions here, notes over here. So example 2. We have x to the 1/2 equals 2x minus 3 to the 1/2. So this is one where we start with fractional exponents, and remember something to the 1/2 is just the same as the square root of that something. So I'm going to use that idea and change this to the square root of x equals the square root of 2x minus 3. Now I look at this and notice I have radicals on both sides. So there's no way to isolate them anymore. So what I'll do right now is I'll just square both sides. And because squaring and square roots undo each other, that leaves me an x here. All of that squared is just 2x minus 3. I don't need the parentheses now because it's clear that all of that got squared. So at this point, I look and think about moving all my numbers to one side and my x's to the other. So I'll add 3 and I'll get x plus 3 equals 2x, and I'll subtract an x and I'll get 3 equals x. Ding, 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 ding. The end. So again, we could think about whether that would give us imaginary numbers. 2 times 3 is 6. 6 minus 3 is 3. Over here we just put a 3. 3 to the 1/2 equals 3 to the 1/2. So we are good to go. Let's do another example. This one is going to be a cube root function. And with cube root functions, we actually don't have to worry about checking our answers because there's not that domain restriction like there was in square roots. So cube roots, let's see. First example is the cube root of x plus 2 plus 7 equals 5. So one thing to notice here is that this plus 7 is outside of the cube root. So the first thing I'm going to do is I'm going to subtract 7 on both sides to isolate my cube root. And I'm putting the parentheses here so it's really clear what's inside and outside the cube root. If you wanted to write it without, that would be totally fine. Equals negative 2. So now I've got my cube root by itself, so I'm going to cube both sides. When I cube the left side, I get x plus 2. When I cube the right side, I get negative 2 cubed, which is negative 2 times negative 2, which is 4. 4 times another negative 2 is negative 8. Almost got x by itself. I just subtract 2 on both sides, and I get x equals negative 10. So my answer is x equals negative 10. Yeah. So far, so good. Okay. Let's do one more. Example 4. I think this one will also fit here, so I'm just going to do it at the bottom of the page, and we'll be done before you know it. 2 x minus 50 to the 1/3 equals negative 10. So in this one I need to rewrite this with a cube root, but notice that this 1/3 is just with the x minus 50, so it's 2 times the cube root of x minus 50 equals negative 10. So now I want to get rid of the 2 by dividing both sides by 2. So the cube root of x minus 50 equals negative 5. Well, to get rid of the cube root, I cube both sides. Cube it, cube it. So x minus 50 equals negative 5 cubed. Negative 5 times negative 5 is 25. 25 times another negative 5 is negative 125. I add 50 on both sides, and I get x equals negative 125 plus 50 is negative 75. That's all there is to it. Occasionally you'll get quadratics, not all the time, not very often, because I want to know if you can undo cube roots and square roots at this point. So yeah, any questions? Jot them down in this handy space in the margin, bring them to class, and I'll see you soon. Thanks and have a wonderful day. Ciao.